Hello all, welcome to ML Industry. In this video, we will be talking about what is machine learning, what are the different types of machine learning, what are the common steps followed to solve a machine learning problem, and applications of machine learning. So let's start with the first question. What is machine learning? Well, machine learning is a way to teach computers how to do things by giving them lots of examples to learn from. It's like teaching a child to recognize a cat by showing them lots of pictures of cat until they start recognize common patterns like pointy ears, furry tail, etc. In the same way, we can teach a computer to recognize a cat by showing it a lot of pictures of cat and telling which one are cat and which one are not. Once the computer has seen enough data, it starts to find patterns on its own, like the shape of the ear, the color of the fur, and other features that help it identify cats in new pictures it has not seen before. This is similar to how a baby learns to recognize a cat, even if it's a different color or has a different shape that it has not seen before. Only by giving the computer a lot of example and letting it find the patterns on its own, we can teach it to do a lot of things that would be very hard or time consuming for humans to do manually. I hope that gives you the brief idea of what machine learning is. Now, let's see what are the different types of machine learning. Well, there are three main types of machine learning. One is supervised, one is unsupervised, and one is reinforcement. Supervised machine learning is a way to teach computers to predict by giving it a lots of example data where we have already labeled it with correct answers. Like if I give you the same example, if I teach a child to recognize color by pointing at different objects and saying what color they are. For example, you might show a child a banana and say this is yellow. And then you show the child an apple and say this is red. So in unsupervised learning, we do the similar things. We give computer a lot of example with the correct answer, like pictures of fruit with labels that say what kind of fruits they are. We call this training data. The computer uses these labeled examples to learn how to make predictions or on a new unlabeled data that we know as test data. So test data does not have any label associated with it. Training data has labeled associated with the data. It's like giving a child a new fruit and ask them what color it is. And they can use what they have learned from the labeled examples to exactly decide what color it is. Right? So the goal of supervised learning is to build a model that can make accurate predictions on new, unseen, unlabeled data. The more labeled example we give to the computer, the better it can learn how to make accurate predictions. It's like teaching the child more and more colors with more and more examples so that they can get better at recognizing the colors. I hope the supervised learning is clear. Now let's see what is unsupervised learning. Unsupervised machine learning is a way to teach the computer to find patterns and relationships within the data without giving it any labeled examples. Okay, so here we are not giving any labels. It's like discovering new types of fruit by looking at their physical characteristics without anyone telling you what they are called. So in unsupervised learning, we give computer a set of data and ask it to find patterns and relationship on its own. This can be useful for things like clustering similar data points or identifying outliers in a dataset. For example, Imagine you have a basket of different fruits and you want to organize them into groups based on their physical characteristics. You could use unsupervised machine learning to group these fruits together based on similar size or shape or color or texture without anyone telling you what each fruit is called, right? So this is like letting the computer to look for the patterns in the data without any prior knowledge of what that data represents. Okay, so unsupervised machine learning can be used of variety of applications such as identifying patterns in customer behavior or clustering similar images or something like that. So it can help uncover insights and relationships in data that might not be immediately obvious to human observer. Clear? Okay. Now let's see the third type of example, that is reinforcement machine learning. Reinforcement machine learning is a way to teach the computer to make decisions based on rewards and punishments. Now, how this works? This is similar how we train a pet to perform tricks by giving it treats for good behavior. In reinforcement learning, we give the computer a task to perform and provide feedback in the form of rewards or punishment based on its action. The computer then uses that feedback to learn and improve its decision making over the course of time. For example, imagine you are teaching a dog to fetch a ball. Okay. Now you might give the dog a treat every time it successfully retrieves the ball and brings it back to you. But not give it a treat if it fails to retrieve the ball or bring it back too slowly. This is like providing feedback to the computer in reinforcement learning, with the treats serving as rewards for good behavior and the lack of treat serving as a punishment for bad behavior. So in reinforcement learning, the computer tries to maximize the rewards over the time by the learning and getting the feedback from its previous actions. It can be used for things like game playing, robotics, autonomous vehicles, and stuff like that. For example, a self-driving car could be a good example of reinforcement learning to learn how to navigate through roads safely and efficiently by receiving rewards for driving smoothly and following traffic laws, and punishment if it cause accidents or breaking the traffic rules. So that is a very generalized example of how reinforcement learning can be used. Okay, so I hope you guys have a fair idea of different types of machine learning. Now let's look at what are the common steps in machine learning problem, or I should say what are the common steps to solve a machine learning problem. Now we have a generic idea, but there are no one size fits all approach to solve machine learning problems. We will cover common steps involved in solving any machine learning problem that you can follow. Okay, and if you develop to follow these steps, you will develop a machine learning model that is efficient, effective, and accurate. So the first step is define the problem. By define the problem, I mean you clearly define what you are trying to solve. What is the business goal you are trying to achieve? What is the question you are trying to answer? Okay, so it's very important to have a clear understanding of the problem you are trying to solve, as this will guide the entire machine learning process. So until you don't know what your end objective is, what is the variable you are trying to predict or you are trying to classify, keep asking question unless it becomes clear to frame the problem in terms of different steps that follow after the problem definition. Okay, so defining the problem to exact point is the most important and the first step of the machine learning process. Now once you define the problem, the next step is gathering data. This may involve collecting new data, cleaning the data, and preparing existing data. and ensuring the data is representative of the problem you are trying to solve. Without high quality data, your machine learning model will not be able to make accurate predictions. So gathering the data is the second step. In third step, you will do exploration. So once you have the data, you will want to explore it to gain a better understanding of what it represents. This may involve visualizing the data, identifying patterns, and detecting outliers or missing values. Exploring the data will help you identify any issues need to be addressed before you can use it for training your ML model. Okay. Now, once you have done exploring the data, the next step is prepare the data for your model training. This may involve cleaning and transforming the data, scaling and normalizing features, splitting the data into training and test set. Preparing the data is very important step that will help to ensure that the machine learning model can learn from the data effectively. Okay, so the steps that we have mentioned till now, these two steps, exploration and preparation of the data, can take most of the time. Now, assuming all these four steps are covered, next comes choosing a model. With the data prepared, you can now choose a machine learning model that is appropriate for the problem you are trying to solve. This may involve selecting a model from a pre-existing library or developing a custom model. The choice of model will depend on the problem you are trying to solve and the data you are working with. Okay, now in step 6, once you have chosen the model, you will need to train it with your prepared data. Okay, so the sixth step is train the model. This involves feeding the training data into the model and allowing it to adjust its parameter to improve its predictions. Training the model is an iterative process, and that may require multiple rounds of training and evaluation. Okay, now once you have finished the training, in the seventh step you will do evaluation of the model. You will want to evaluate what's the performance the model will give on an unseen data that we know called test data, right? This may involve using the metrics such as accuracy, precision, recall, F1 score, or root mean square error, or mean absolute error, or whatever the measurement matrix is. We call it KPI, key performance index. So that depends on your problem itself. You choose the KPI and you evaluate your model performance based on that API. How much accuracy your model is giving, or how precise your model is, and what is the recall score. So if you don't know these terms, don't worry, I will explain these individual terms in a separate video. Okay, but now let's focus on the steps for the time being. So evaluating the model is a very important step that will give you the idea of how effective your model is. If you find your model is not performing well, you go back to training your model by tuning the model parameters, or you may go back further to prepare the data or create new features or scale or normalizing the feature in different way, and then come back to training and evaluation again. So these steps are iterating in nature. Okay, so once you have evaluated the model, then if the model performance is not satisfactory, you can always also do the tuning the model that I just said. After the evaluation, you can go and tune the parameters and try different models. This may involve using techniques like cross validation, hyperparameter tuning, to optimize the performance of your model. So to make your model giving out satisfactory results or accuracy or performance, there are several steps like hyperparameter tuning, checking with cross validation, And if that is also not satisfactory, then you may go back to prepare the data again differently and train with the same model or different model. So this can take multiple rounds of training, evaluation and tuning. Okay. Now, once you have done tuning the model and you have finalized the model, step 9 is to deploy the model. So you have a satisfactory model performance. Now you can deploy that model into production environment to make predictions on new unseen data. Okay, this may involve integrating the model into a larger system or developing a user interface for end users. Now, what I am trying to indicate by integrating the model into larger system means you need to create the pipeline where if the unseen data comes, it may go through certain process to prepare the data the way the model can evaluate, right? So model can give prediction on an unseen data only if the data is represented in certain way, right? So your unseen data has to go through certain steps to be the representative of same kind of data that it is used to train the model, right? So it may include feature engineering, it may include cleaning the data or other processes. So you will create that pipeline in production, and then at the end of it you put that model. So the model will perform predictions of the data that has gone through that pipeline and give you the output. So that entire thing happens in the deployment. And once you have deployed the model, congratulations, your ML lifecycle is done. Okay. Okay, now let's see what are the applications of machine learning. So machine learning has many different practical applications across a variety of industries. I will give you some of the application in different industries. Like in healthcare, machine learning is being used to analyze patient data and make predictions about disease outcomes. You may have already know that there are a cancer data set out there publicly available to classify if a tumor is malignant or not, right? So that if although it is a practice data set, but this kind of application is actually happening in healthcare where the doctors are using machine learning algorithms to find out certain disease or conditions like diabetes or heart disease, etc. Similarly, in finance, ML is used for fraud detection, credit risk analysis, portfolio management, and things like that. For example, banks and credit card companies are using machine learning to detect fraudulent transactions and alert their customer in real time. That is very hard for company to manage by human interventions, right? Machine can work 24/7 and give you real time updates. So that is being happening because of the use of machine learning. Similarly, in the marketing field, ML is being used for customer segmentation, product recommendation, personalized advertising that you see on Facebook or Instagram or stuff like that. You may have experience that if you go to some e-commerce website and search through certain categories, an hour later or so your Instagram profile or Facebook profile reflects similar kind of advertisement on their page. So that is what the output or application of machine learning itself, nothing else. So it analyzes customer data and suggests products that are likely to be of interest of that customer. Similarly, in manufacturing, ML is being used to let's say detect if a equipment is likely to fail and schedule maintenance before the failure occurs. In transportation, ML is being used for route optimization, traffic prediction, autonomous driving, etc. etc. Similarly, for natural language processing, ML is being used, right? You may heard of ChatGPT, that is the most recent example of NLP, natural language processing. Other than that, there are chatbots, virtual assistants, sentiment analysis, etc. in that are the applications of machine learning. So there are endless example we can discuss, but to give you a brief idea where ML is being used, I have given you these examples. And as this field is evolving and it is changing rapidly, we can expect to see even more innovative examples and applications in near future. So I hope you have a clear idea about machine learning and how it works. I hope you find this video useful. If that is the case, please give it a thumbs up and share it with your friends. And if you're new to this channel, I urge you to subscribe my channel. See you in the next video. Thank you.